Hi everyone, today we'll talk about our product Better Planning for Fatal Times. Next slide. As the name may have hinted, we have created a product that can help patients plan for crucial moments where they need to make a decision about whether to receive life-sustaining treatments or not. The problem patients face now is when such a time comes to make this critical decision, they may not be in a cognitively or physically available state to do so. Therefore, there's something called the ACP. It's a planning tool that helps patients document their preferences given a critical scenario. Next page. Unfortunately, the current ACP leaves much to be desired. The process of filling one out is very manual and hard for patients to go through. And despite the ACP being a lengthy survey, they may not address comprehensive scenarios. So we built a full stack machine learning driven web app deployed at server with a database to address these problems. We aim to solve the two problems mentioned earlier by developing a user-friendly experience and supplement documented user preferences with machine predicted patient preferences to cover even more scenarios. And now we will go through a demo of the product that we built.
So here's the address for our demo. It's public from anywhere, so any user can just access it with a browser. No other requirements. And the first page for our product is the start page, which we have a introduction of what our product is to give a user an idea what the whole thing's about. And then we just started. The first question is to enter your name. Here, just enter my name, and then this is just to keep a record for the user. And for in the future, we might incorporate more demographic features such as sex or age. And then this is what the actual question like. So we ask the users if they still want to receive life-sustaining care under these situation. And this situation is connected by and, so these should just assume to be appear all together. And then all the questions are binary, so the user just choose either yes or no. And then go to the next question. So the next question is generated from our machine learning model based on the previous answers to get a quick idea to learn what the user's preference is. And you can see the question style are all the same, but just changing different combination of situation. And here is the feature importance graph we have, which will give a user like a guideline or like a assistant tool to let the user know how important different feature they have. And so we have like 25 questions. I'll just do it quickly for now, because in the demo, due to time limitation. While I'm doing that, we also give a brief introduction of our algorithm.
So the basic algorithm is based on random forest, and based on that, active learning is entropy-based, which means at each round, the model is trying to find the next instance that could maximize the entropy score. And in addition to that, the model also captures kind of the domain constraints from this problem. Basically, if a question is composed by a subset of features, let's say A, B, C, and then if the users answer yes to that question, then any question that is composed by the subset of ABC will also result a yes. And similar thing can be also applied to answer no. And such domain constraints enable us to kind of do a data augmentations based on user response. So we use this active learning approach plus data augmentations for sampling the questions.
Okay, so yeah, we are now approaching the end of the survey. So after all the questions, we'll have the last question, which is let the user to provide some feedback. The feedback can be anything about the survey question itself, or about the user experience, or about if the visualization part is helpful. And actually, we receive many useful and helpful feedback, and we actually apply and improve our product based on those feedbacks. And after you submit the feedback, it will be the last page, which is an evaluation page. So here we generate 10 additional questions that the user haven't seen before, and then provide the answer yes or no based on our model. And at last, the user will just give us a rough score, like 8 out of 10 or 7 out of 10, to let us get a evaluation idea for our like how well our product is. Okay, now let's move back to the presentation.
So this is kind of the feedback we got from the participants. The first one is add a progress bar to help patients know when or what's to come. And then the visualizations need captions and patients' evaluation of the model. So basically, if patients consistently reflect the specific principles, meaning they have some kind of rules in head that they want to choose yes or no, then predict answers kind of reflect that. But some patients do feel like it's very hard to be consistent throughout the survey, then the results is not so good. And then we have questions can look similar to one another is because we have 10 features and all the questions kind of generated by subsampling the features. And at the very end, we have a summary at the end could help patients know what was collected by the survey. So the feature step, the first one would be a couple of practice questions to help patients anticipate what to expect. And another one is dynamic number of questions with human in the loop. So right now, the 25 questions and then 10 evaluations cannot decide arbitrarily. But in practice, we propose this should be a loop process, which means a patient should have a kind of accuracy expectations. Then he or she answered a subset of questions. Then we do evaluations. And this is a looping process until the patient's thinks accuracy meets their expectations. And obviously, we could collect more data for validating the active learning algorithms and probably add prior to the active learning. And the last one is ACP model to be adapted for different disease. Right now, we only cover stroke. We could potentially cover more diseases as we have more, I guess, domain help from other medical experts. Yeah, that's pretty much it.